In Algebra 2, Section 2.5, we're dealing with scatter plots and also the line of fit, which is what we usually do in life, because as nice as patterns are when we're graphing, things like population, sales, stuff like that are not always at a certain pattern or exact prediction. So that's where scatter plots come in, where you have real life information. It doesn't necessarily go up or down at the same rate every year for 10 years. It's possible, but doesn't mean it happens because it's, real life. So what scatter plots do is it kind of takes your information and it organizes in a way so that you could find somewhat of a pattern. Now, it won't be applicable necessarily and give you an exact answer, but it can give you an estimate. Like when we're dealing with schools and stuff like that, and we want to know in the public system how many chairs that we need. Well, for all we know, we could have a whole bunch of families moving in because a company started up there. But until then, we're thinking that it's a steady rate, not exact, but steady. So that's where scatter plots come in. So we're dealing with either a positive correlation, a negative correlation, or no correlation. So basically, no correlation means the information is too scattered for us to be able to really see if there's a pattern. Positive correlation is basically as one variable goes up, so does the other. So for example, the bigger your house is, the more electricity you use. So the bill, even though it's not in the same pattern every time, the bill will go up as the house gets bigger. That's called a positive correlation. I mean, it won't be a positive thing if your bill goes up, but it is positive correlation. Negative correlation is basically as one gets bigger, the other one gets smaller. So if we're dealing with I really can't think of an example. But if one thing but as time goes on, and you have less and less money, like the amount of money you have in your savings, the more you spend, the less you have in savings. So basically that's a negative correlation. Number 1 is asking us to make a scatter plot of the table that approximates the percent of students who applied to 2 colleges. So this is the year since 1895. So these represent years. So for example, the first one, 0, means it's 1895. The next one is 3 years from 1985, so it's 1986. The reason why they do this instead of put the dates is that trying to graph 1985 is a big number, so that that's where these numbers come in. And the percentage of kids who applied to 2 colleges or more. So the top is my X. This is my independent, and the bottom is my Y, it's my dependent. According to what year it is, that's the percentage, okay? The percentage doesn't affect the year. Time will go on no matter what. So these on the x-axis, are going to be the independent variables. So our year is independent. So we're going to go here, and this will be our year since 1985, and this is our percent. Okay? Now, the top and bottom can go on different patterns, but they have to go at a pattern. So these ones go by 3s, it seems. So we're going to go 3, 6, 9, 12, 15, 18. The bottom is 20, 18, 15. So I'm going to, if there's not a set pattern like this one, I'm going to pick I'm going to look at the smallest and lowest and then find a way to get from one to the other. So our lowest seems to be 13, our highest seems to be 20. So let's go by 2s. So 2, 4, 6, 8, 10, 12, 14, 16. Then we can graph. We have 0 to 20, which is right here. 3 to 18. 6 to 15. 9 to 15. 12 to negative 14. No, sorry, 14. And 15 is 13. So it seems like it's decreasing. It increased a little bit. So this has sort of it's mainly a negative correlation. You see that? If we kept going and then it kept going up and down, it would be no correlation, but it's somewhat negative. And what we're going to do now is try to find some pattern in that chaos and see if we can come up with an equation that will help us predict future percentages for kids who apply to colleges. So I'm going to find a line that I can draw through these points. The goal is to find a line that goes through at least 2 points. If it goes through, it can go through more, but at least 2 points. But I can do it. You see how if I do it through these 2 lines, it'd be okay. It'll hit 2 points, but all the other remaining dots are on top of this would-be line. My goal is to create a line that goes through 2 dots, and then all the dots that don't hit the line are evened out as much as possible with top and bottom. So, for example, if I get maybe these 3 points right here. So it goes through these 3 points. Okay. And then I have 1 dot left over and 2 in the bottom. That's okay. If I had 4 in the bottom and 1 on top, I might need to rewrite, but I'm just doing the best I can with the information I have. And from there, I'm going to do 2 points from the graph. I'm going to choose this one and this one. So I have 0, 20. And your answers are going to be different because some of you guys will draw your line of fit differently. This one, the 4th one, is 9, 15. Okay? Once I do this, once I find these 2 points, then the line of fit is just using what you used for the last sections, and y equals mx plus b to find the equation of the line. That's what I'm doing with these 2 points. It's just finding that those 2 points are the struggle. So let's start with m, x1, y1, x2, y2. So we have m equals 15 over 20, and then 9 over 0. So we have 5 over 9. Sorry, negative 5, because 15 minus 20. So negative correlation matches this. If this was positive, I'd be nervous because it means that this looks negative, but yet somehow I got positive and something went wrong. But we have negative correlation. And now, in order for me to have a line of fit or an equation, I need an m and a b, and I only have an m. So I'm going to use one of these points. I'm going to use the first one. It doesn't matter which one. But I'm going to use one of these points to find my b, just like the other sections. So I'm going to try the first point. 20 equals negative 5 over 9, x, which is 0, plus b. So this is 0. 5, negative, anything times 0 is 0. So 0 plus b is 20. So 20 equals b. So my equation with b and my slope is y equals negative 5 over 9x plus 20. This is my equation for b, right? And now I can predict any year. So 2010 from 1980, I have to figure out how many years. So from 1985, 2010 will be so to 2000 it's 15. So from 1980 it would be 25. So now I need to find 25, and C is asking me what's here. What's the percentage in 25 years from 1985? So I'm going to plug 25 in for my x. You see how that goes? So y equals negative 5/9 times 25 plus 20. Okay? So P needs to get her calculator. So negative 5/9. So I'm going to do 5 divided by 9 to find the decimal. So negative 0.555 times 25, which is negative 13.89 plus 20 equals y. Gets me 6.1%. So in 25 years, only 6.1% of students will apply to colleges. See how that works? Okay? You find 2 points on the line of fit, find the equation, and then from there, you can plug in anything for x or y to solve, be able to predict for future years or future times. So go ahead and write this down and try page 95, number 1, page 95, number 1, and I will see you in class.